Yes, all kitchen equipment that requires a plug must be GFCI protected. This requirement is outlined in the National Electrical Code, specifically in Article 210.8a, which addresses ground fault circuit interrupter protection for personnel. The section focuses on electrical outlets. However, there is an exception. Kitchen equipment that is permanently connected to a branch circuit in accordance with 210.5 and that has the equipment grounding conductor connected to a grounding electrode or bonded to a grounded neutral conductor in accordance with 250.113 A and B does not require GFCI protection. Let's break down these code references to fully understand the requirements and the exception. Article 210.8 mandates GFCI protection for 125-volt, 15 and 20 ampere receptacles installed in dwelling unit locations. This generally includes all such receptacles in kitchens, bathrooms, garages, and outdoor areas. The purpose of GFCI protection is to prevent electrical shock. A GFCI monitors the current flowing in a circuit. If it detects that current is leaking to ground, indicating a potential shock hazard, it quickly interrupts the power. This interruption happens in milliseconds, significantly reducing the risk of serious injury or death. In the context of kitchen equipment, any appliance that plugs into a 125-volt, 15 or 20 ampere receptacle must be GFCI protected. This includes items such as countertop appliances, blenders, toasters, coffee makers, and portable cooking equipment. The reason for this requirement is the high risk of electrical shock in kitchens due to the presence of water and other conductive materials. Now let's examine the exception. The exception states that if the kitchen equipment is permanently connected to a branch circuit and properly grounded, GFCI protection is not required. This exception applies to appliances that are hardwired, meaning they are directly connected to the electrical system without a plug and receptacle. Article 210.5 addresses the identification of branch circuits. It requires that each ungrounded conductor of a branch circuit be identified by phasor polarity at all termination, connection, and splice points. This identification is typically done using color coding such as black, red, and blue for different phases in a three-phase system, and white for the neutral conductor. The purpose of this identification is to ensure that electrical connections are made correctly, which is crucial for safety and proper operation of the equipment. Now let's consider the grounding requirements outlined in 250.113 and B. Section 250.113 addresses the connection of the equipment grounding conductor to a grounding electrode. A grounding electrode is a conductor or group of conductors that are buried in the earth and used to provide a path for fault current to return to the source. This path is essential for the proper operation of overcurrent protective devices, such as circuit breakers and fuses, which will trip and de-energize the circuit in the event of a ground fault. Common types of grounding electrodes include ground rods, ground plates, and underground metal water pipes. The equipment grounding conductor must be connected to the grounding electrode system to ensure that the equipment is properly grounded. Section 250.113b addresses the bonding of the equipment grounding conductor to a grounded neutral conductor. Bonding is the process of connecting conductive parts of an electrical system to create an electrically conductive path that is capable of safely carrying fault current. The grounded neutral conductor is the neutral conductor of the electrical system, which is intentionally grounded at the service entrance. Bonding the equipment grounding conductor to the grounded neutral conductor provides a low impedance path for fault current to return to the source, which is essential for the proper operation of overcurrent protective devices. In the context of kitchen equipment, this means that the metal frame or enclosure of the appliance must be connected to the grounding electrode system and bonded to the grounded neutral conductor. This connection can be made using a grounding wire or other approved means. The purpose of this grounding and bonding is to provide a safe path for fault current to return to the source in the event of a ground fault. This will cause the circuit breaker or fuse to trip, energizing the circuit and preventing electrical shock. Let's summarize the key points. All kitchen equipment that requires a plug must be GFCI protected, according to Article 210.8 of the National Electrical Code. This requirement applies to 125 volt, 15 and 20 ampere receptacles in dwelling unit kitchens. The purpose of GFCI protection is to prevent electrical shock by quickly interrupting the power in the event of a ground fault. An exception exists for kitchen equipment that is permanently connected to a branch circuit and properly grounded, in accordance with 210.5 and 250.113 RMB. This exception applies to hardwired appliances that are directly connected to the electrical system without a plug and receptacle. These appliances must be properly grounded and bonded to ensure that fault current can safely return to the source. To ensure compliance with the National Electrical Code, it is essential to consult with a qualified electrician when installing or modifying electrical systems in kitchens. The electrician can assess the specific requirements of the installation and ensure that all equipment is properly grounded and protected. Furthermore, it is important to regularly test GFCI receptacles to ensure that they are functioning properly. This can be done using a GFCI tester, which is a simple device that plugs into the receptacle and simulates a ground fault. If the GFCI receptacle does not trip when tested, it should be replaced immediately. By following these guidelines, you can help to ensure the safety of yourself and others from electrical shock in the kitchen. The NEC is updated regularly. Consulting the latest edition ensures compliance with the most current safety standards. The goal of GFCI protection is to minimize the risk of electrical shock. Water and electricity are a dangerous combination, particularly in kitchens. The use of GFCI protection is a critical safety measure. Proper grounding and bonding are also essential for electrical safety. These measures provide a safe path for fault current to return to the source, preventing electrical shock. If you have any questions about GFCI protection or other electrical safety topics, consult with a qualified electrician. They can provide expert advice and guidance. In addition to GFCI protection, there are other electrical safety measures that should be taken in the kitchen. These include using properly insulated electrical cords, avoiding overloading circuits, and keeping electrical appliances away from water sources. These measures can help to prevent electrical shocks and fires. The National Electrical Code is a comprehensive set of standards for electrical safety. It is essential to follow the NEC when installing or modifying electrical systems. The NEC is updated regularly to reflect the latest advances in electrical technology and safety practices. It is important to consult with a qualified electrician to ensure that your electrical system complies with the NEC. Electrical safety is a critical concern in the kitchen. By following the guidelines outlined in this discussion and consulting with a qualified electrician, you can help to ensure the safety of yourself and others from electrical shock. Remember that working with electricity can be dangerous. If you are not qualified to work with electricity, always hire a licensed electrician. The seemingly straightforward exception regarding permanently connected equipment requires careful consideration. Firstly, the term permanently connected implies a hardwired connection, not simply an appliance that is rarely unplugged. The appliance must be directly wired into the electrical system. Secondly, compliance with 210.5, the identification of branch circuits, is crucial. Proper color coding and labeling of conductors is essential for safe and correct wiring. Thirdly, and perhaps most importantly, the grounding requirements of 250.113 MB must be meticulously followed. The equipment grounding conductor must be properly connected to a grounding electrode system, which could involve a ground rod, ground plate, or connection to a metal water pipe. Furthermore, the equipment grounding conductor must be bonded to the grounded neutral conductor, creating a low impedance path for fault current. Consider a commercial kitchen with a large, permanently installed mixer. This mixer is hardwired to a dedicated circuit. To comply with the exception, firstly, the wiring must be properly identified according to 210.5 with correct color coding. Secondly, the mixer's metal frame must be connected to the building's grounding electrode system, typically through a grounding wire run back to the electrical panel. Thirdly, this grounding wire must also be bonded to the grounded neutral conductor at the service entrance or at a separately derived system. In this scenario, GFCI protection would not be required for the mixer. However, it is imperative that all grounding and bonding connections are properly made and regularly inspected. If the mixer were to be replaced with a similar model, these connections would need to be re-established. Conversely, if the mixer were to be replaced with a plug-in model, GFCI protection would then be required for the receptacle serving the mixer. In residential kitchens, the same principles apply. A permanently installed cooktop or oven hardwired to a dedicated circuit and properly grounded and bonded would not require GFCI protection. However, any plug-in appliances, such as microwaves, toasters, or blenders, would need to be served by GFCI protected receptacles. It is important to note that simply having a 3-prong plug on an appliance does not guarantee adequate grounding. The grounding wire within the appliance's cord must be properly connected to the appliance's frame and to the grounding pin on the plug. Furthermore, the receptacle must be properly grounded, with a grounding wire connecting the receptacle's grounding terminal to the electrical panel's grounding bus. In older homes, it is not uncommon to find ungrounded receptacles. Replacing these receptacles with GFCI protected receptacles is a common way to provide a measure of safety, even if the grounding system is not ideal. GFCI protection can still prevent electrical shock by detecting current leakage even without a direct path to ground. However, it is always preferable to have a properly grounded electrical system. When in doubt, consult with a licensed electrician to assess your kitchen's electrical system and ensure compliance with the National Electrical Code. They can identify any potential hazards and recommend appropriate solutions to improve safety. Remember that electrical safety is not just a matter of code compliance, it is a matter of protecting yourself and your family from electrical shock. Investing in proper electrical safety measures is a small price to pay for peace of mind. In summary, while GFCI protection is generally required for all plug-in kitchen equipment, the exception for permanently connected and properly grounded equipment provides a pathway to compliance without GFCI in specific circumstances. However, meticulous attention to grounding and bonding requirements is paramount to ensure safety. Always prioritize safety and consult with a qualified electrician when dealing with electrical systems. The National Electrical Code serves as the definitive guide for electrical installations. Regular updates to the NEC reflect ongoing advancements in safety practices and technology. Staying informed about these changes is crucial for electrical professionals and homeowners alike. The NEC is not merely a set of rules, it is a comprehensive framework for ensuring electrical safety. The code addresses a wide range of topics from wiring methods to overcurrent protection to grounding and bonding. Understanding the principles behind the NEC is essential for making informed decisions about electrical installations. GFCI protection is just one aspect of a comprehensive electrical safety strategy. Other important elements include proper wiring techniques, adequate overcurrent protection, and regular inspections. Electrical safety is a shared responsibility. Homeowners, contractors, and electrical professionals all have a role to play in ensuring that electrical systems are safe and compliant. By working together, we can reduce the risk of electrical shocks and fires. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always exercise caution and follow safe work practices when working with electricity. If you are not qualified to work with electricity, hire a licensed electrician. The cost of hiring a qualified electrician is a worthwhile investment in your safety and the safety of your property. Don't take chances with electricity. Hire a professional and ensure that your electrical system is safe and compliant.